Morning, ladies and gentlemen, boys and girls, friends and neighbors. Let's have a discussion about complex numbers 101. This is probably going to take 2 videos, so we'll see how much I can get through one video. I'm going to make this video last maybe 20-25 minutes. We'll see. So we're going to talk about complex numbers, and a complex number is a number. It's a number that has a real part and an imaginary part. Okay? You will see these complex numbers in the form a plus bi, where a and b are real numbers. These are real numbers, and this imaginary number I. So I is the imaginary number. So a complex number is the sum of a real number and an imaginary part, a plus bi. For an example, here's an example of a complex number, 5 plus 7i. Now 5 and 7 are real numbers. 5 is the real part of this complex number, and 7i is the imaginary part of this complex number. We'll talk more about I here in a little bit. And so it being a number, a complex number is a number. It's a complex number. What we're going to learn in the next 2 videos, we're going to learn how to add. We're going to learn how to subtract. We're going to learn how to multiply, and we're going to learn how to divide complex numbers. The same for operations that we do to real numbers. So here we go. So the first thing we need to look at is this guy right here that we call I, the imaginary number I. What in the world is I? Well, I has a very clear definition. I has a definition. The definition of I is simply this. I is the square root of -1. This is the square root of -1 is equal to I. That tells me that I squared is equal to -1. So I squared is -1. I is the square root of -1. There's 2, and both of these imply the same thing. So I can have I squared as -1, or I is equal to the square root of a -1. And I is an imaginary number. It's not real. And if I go back to the realm of square roots, we know, and we learned in geometry, and we learned earlier in our algebra years, that you cannot square root a negative number. So this number here, this is not a real number, this guy right here. And we've been very specific that you cannot square root a negative number. Well, it's a not real number. In the realm of real numbers, you can't square root of negative numbers. Now that I have this new definition of I can square root of negative. I can simplify the square root that has the inside radicand as a negative. And here's how we do it. We're simply going to look at, say I want to simplify the square root of -16. Well, the square root of -16 is the square root of -1 times square root of 16. What I'm going to do is I'm going to write this as the square root of -1 times the square root of 16. Why can I do that? Because 16 times -1 is -16 there. And so what's the square root of -1? The square root of -1 is I. Square root of 16 is 4, and we knew that for a long time. So what does that tell us? That tells me that the square root of -16 is 4i. It's an imaginary number. So this 4i is the simplified version, if you will, of the square root of -16. So let's do the square root of another negative number. Right here I have the square root of -18, looking at this rascal right there. When you see a negative under the radical expression, when the radicand, what's underneath the radical expression, is negative, first thing you do is you pull that negative square root of -1 out. So this is going to be the square root of -1 times the square root of 9 times square root of 2, and we know that 9 times 2 is 18. The reason why we did that is I know what the square root of 9 is 3. The square root of 2 remains square root of 2. This is old geometry here. And the square root of -1 is I. So what does that tell me that the square root of -18 is? 3i square root of 2. So the square root of negative 18 is 3i square root of 2. Who would have thought? Let's do another example here, one that's not worked out. Okay, so I have a square root of a negative number. First thing we do is we're going to write that as the square root of negative 1 times the square root of 450. And now I'm back in geometry class where I'm simplifying square roots, and I need to think about, does 450 have any factors that are perfect square? And I know that $450 is 9 times 50. 9 times 50 is 450. So the square root of 9. So the square root of negative 1 is I. I have an I here. And this is a 3, square root of 9. And now I have to look at 50. Does 50 have any perfect square factors? Yes, it does. So I'm going to continue to break this 50 down as the square root of 25 times the square root of 2. And we know what the square root of 25 is, 5. So I have I have 3, I have 5, and I have the square root of 2. And keep in mind, all of those things are multiplied together. So what is our final simplification is going to be 3 times 15, 15i. You always want to write the number in front of the I, square root of 2. So the square root of negative 450 is equal to 15i square root of 2. Next page of notes. So recall from the previous math, and I have from previous math classes, and I have used these two properties already. Well, I've used this first property already today. So the square root of a times b is equal to the square root of a times the square root of b. We've used this property today, and we've used it in previous math classes to simplify square root expressions. And the other property number, so this is property number 1, this is property number 2. The square root of a divided by the square root of b is equal to the square root of a over b. The key to those two properties, they only work if a and b are positive real numbers. They only work if a and b are positive real numbers. If I go back to my previous page, I'm going to right here. I'm going to go slide back to my previous page. I did use this property here, but what I have to realize is if you have a negative, the first thing you need to do is take the square root of negative 1 out of that. Now when I'm here, now I'm going to use that property on the next page. Step number 1 is always take the square root of negative 1 out first. And let me show you how we have to be very careful. If I have the square root of negative 3, as I have here, times the square root of negative 3, if I just look at this property right here, I would think that, oh, that this should be the square root of negative 3 times negative 3. Well, negative 3 times negative 3 is 9. So is the square root of negative 3 times square root of negative 3 is going to be the square root of 9, which is 3. And it's a really good argument. The problem with that argument is it's not true. And here's why it isn't true. And this is what we have to be very careful with. If you have the square root of negative 3, the first thing you have to do is pull the square root of negative 1 out. Again, if you have the square root of negative 3, the first thing you have to do is pull that square root of negative 1 out. So now, negative 1 times 3 is negative 3. Negative 1 times 3 is negative 3. That's why I can separate that. Hey, but what is the square root of negative 1? The square root of negative 1 is I. Square root of negative 1 is I. So here I have I square root of 3 times I square root of 3. I have I square root of 3 times I square root of 3. So I have I times I squared. Square root of 3 times square root of 3 is indeed 3. What's I squared? Negative 1. Oh, there you go. So the square root of negative 3 times the square root of negative 3 is negative 3. You have to be careful using that property. Okay, here's another example. The square root of 28 divided by the square root of negative 28 divided by the square root of 7. First thing you do is you take that square root of negative 1 out, which is I. So the negative square root of negative 28 is equal to the square root of negative 1 times the square root of 28. And this guy right here is I. That's where that I comes from. And what do I have left? The square root of 28 over the square root of 7. I can, by this property 2 up here, by this property right here, the square root of 28 divided by the square root of 7 is equal to the square root of 28 over 7, which is 4. Square root of 4 is 2. So this guy right here, the square root of 28 divided by the square root of 7, is 2i. Who would have thought? Another way you can look at this specific problem, you could have done this, the square root of negative 28. There's more than one way to get to the result that you want. You could have gone that first property and said, oh, well, this is negative 28 divided by 7, good deal. And that's the square root of negative 4. And we know what that is. You're going to pull that's going to be the square root of negative 1 times the square root of 4. That's going to be I2. You got the same answer, just a different path. 2i. Very good. So let's look at one more example before we go on to powers of I, and this is going to be the square root of negative 8. So I have the square root of negative 200 over the square root of negative 8, and we have to be really careful. Does this equal this? You have to be careful. Over negative 8. Oh, well, negative 200 over negative 8. That's going to be negative divided by negative is positive. Is that, which is 25, does that equal 5? Does that, I don't know. I don't know. Well, I didn't do what I advised you to do. So let's try that. I better pull the square root. I better write this as square root of negative 1 times the square root of 200 over the square root of negative 1, square root of 8. That's going to be the square root of negative 1 is I over I square root of 200 over 8. I divided by I, ladies and gentlemen, is indeed 1. Oh, so this is the square root of 25, and this time it is correct. So my first reasoning was correct there. But I'm going to tell you, you have to be very careful. Always pull that negative 1 out first. Okay, let's let that soak in a minute. You can always pause the video. Let's go on to the next page then. Powers of I. Before we get to the powers of I, we're going to review some laws of exponents from our algebra class. So we have x to the n times x to the m is equal to x to the n plus m. X to the n to the mth power is equal to x to the n times n, and 1 over x to the n is equal to x to the negative n. These are just laws of exponents. There are many more laws of exponents, but these laws we're going to use to find out some powers of I because they're fairly prevalent in the study of complex numbers. So let's begin talking about powers of I. I to the 1 power is easy enough. It's just I. I squared is negative 1. Why? By definition. This is the definition of I right here. I squared is negative 1. I cubed by laws of exponents is going to be I squared times I, and we know I squared is negative 1. Negative 1 times I is negative I. I to the fourth is I squared times I squared. I squared is negative 1 times negative 1 is 1. So there's the 4 basic properties of I. I to the 1 is equal to I. I squared is negative 1. I cubed is negative I. And I to the fourth is positive 1. So if you have an odd power of I, it's going to be I or negative I. If you have an even power of I, it's going to be negative 1 or 1. Let's examine some examples. Let's look at I to the 17th. What I'm going to do, the objective here is to take these powers of I that you're given and write them as I squared times something, or I squared to some power, because we know I squared is negative 1. So if I have I to the 17th, that's going to be I to the 16th times I, because 1 plus 16 is 17. What I'm doing is employing this property of exponents here. I to the 16th times I to the 1 is I to the 16th plus 1. So I'm employing this first property of exponents right here. Like bases add exponents. I'm going to use this property here in a little bit. Power to a power, you multiply. And later on, I'm going to use this third property. 1 over x to the n is x to the negative n. Let's see how we're going to use those. So let's go back here to I to the 27th. I want to write that as I to the 26th times I to the 1. Why is that true? Because 1 plus 26 is 27. I to the 26th here is going to be I squared to the 13th. Why? Because 2 times 13 is 16. Here I have a power to a power. You're going to multiply. Why did I do that? So I can write this I squared here as negative 1. Now I have negative 1 to the 13th power times I. And if I have negative 1 to the 13th power, it means I'm multiplying negative 1 to itself 13 times. So this guy here is going to be negative 1 as well. Negative 1 times I is equal to negative I. I think I forgot to do this example. Here I have I to the 16th. I did forget to do this example. It's going to be I squared to the 8th, because 2 times 8 is 16. Why did I do that? Because I want this I squared as negative 1. And if I have negative 1 to the 8th, what's that? If I have negative 1, multiply it by itself 8 times, this is going to be a positive 1. 1 times I is I. So here I have an odd power of I that came out to I. Here I have another odd power of I, came out to negative I. So the odd powers of I are going to come out to either I or negative I. The even power are going to come out to 1 or negative 1. So here I have I to the 132nd. Let's do this rascal here. I to the 132nd. That's going to be I squared to the 66. Why? Because 2 times 66 is equal to 132. 132, silly head, not 133. And why did I write that? Because I squared is negative 1. And what's negative 1 to the power of 66? This expression here means that I'm going to multiply negative 1 to itself an even number of times, because that's simply going to be 1. It's going to be positive 1. It's going to be negative 1 times negative 1 times negative 1, 66 times. That's going to be 1. What's that say? Well, that says that I to the 132nd power is equal to 1. You might have to watch this video a time or two. You might have to pause the video and take good notes. Here I have I to the 218th power. I want to write that as I squared to some power. And I go, it's I squared to 109. Why? Because 2 times 109 is equal to 218. I squared is negative 1. Now I have negative 1 to the 109th power. I have negative 1 to an odd number of power. That's going to end up negative 1. What does that tell me? That tells me that I to the 218th power is equal to negative 1. So you have I to an odd power. It's going to end up I or negative I. If you have I to an even power, it's going to end up as 1 or negative 1. You just have to be very careful, and this is the process that you're going to use to figure out, because all powers of I are going to end up as I, negative 1, negative I, or 1. Okay, let's do one more page. We're at about 20 minutes on this video. Let's do one. So this is, look at this. I have I to the negative 5 power. What I'm going to do is I'm going to go back to that third property of exponents from algebra that says this. 1 over x to the n is the same as x to the negative n. And that goes both ways. That tells me if I have I to the negative 5, that's going to be 1 over I to the 5th. Hey, what's 1 over I to the 5th? Now I'm back to an odd power of I. That's going to be I to the 4th times I. What's I to the 4th? 1. So I have 1 over 1 times, this is 1 times I. Let me write this in blue. This is 1 times I. And so if I have 1 times I, I'm not allowed to leave I in the denominator. So this expression is not valid because I don't want I in the denominator. And how do I get I in the denominator? I'm going to multiply the top and bottom by I. And I'm going to multiply this 1 over I to this expression I over I, which is 1. And what's I times I? I squared. What's 1 times I? I. What's I squared? Negative 1. So what is I divided by negative 1? Negative I. What does that tell me? That tells me that I to the negative 5 is equal to negative I. Let's do I to the negative 21. That's going to be 1 over I to the 21st power. I know how to deal with that. That's going to be I to the 20th times I. I to the 20th is going to be this I squared to the 10th. This is negative 1 to the 10th power, which is 1. So again, I have 1 over I, and I know what 1 over I is, negative I, for the same reason. Let's do one more example before we finish this video. So this is going to be, 1 over I to the 7th, which is going to be 1 over I to the 6th times I. And I to the 6th is going to be 1 over I squared cubed. I still have this I on the bottom. This is going to be 1 over negative 1 cubed. I still have that I. Negative 1 cubed is negative. So this is going to be 1 over negative I. I need to get the I out of the denominator. And how do I get it out of the denominator? I'm going to multiply by I over I. So this rascal here is going to be I over negative I squared. Well, what's I squared? Negative 1. So this is going to be 1 over negative 1, which is going to be it's going to be I over negative 1 times negative 1, and that's simply going to be I. I will grant it, ladies and gentlemen, this by no stretch of the imagination is the easiest thing that you've done because it's so new. It uses the laws of exponents, which are difficult for some students. And then you have this whole imaginary number thing going on, which can be a little bit complex, no pun intended. So we're going to pause the video here, be looking for complex number 101 video 2. Have a great day.